Hi guys, today we're going to talk about writing equations of lines and different forms of equations of lines. So the first one that we're going to discuss, we really have three different forms equations of lines we're going to talk about. We're going to talk about point slope form, and again we'll talk about slope intercept form even though we've discussed it briefly already. And the last form we're going to talk about is standard form. Okay, so the point slope form equation of a line, sometimes this is the one that some students don't always see. Some teachers don't introduce this to them because they can always just use slope-intercept form. But if you are given a slope and a point that lies on that line, then the point-slope form equation of a line is given by y minus y1 equals m slope times x minus x1. This looks a lot like the slope formula. If you were to divide by this x minus x1 in parentheses, you would get the slope formula. But it's really useful because oftentimes students struggle a little bit when you're not given the y-intercept in writing the equation of a line. In this particular case, note that, remember this y that's not identified as y1 and this x that's not identified as x1. These two are the variables that will stay in the equation. So we're not going to replace those with values. We will replace x1 and y1 with numerical values that are given and an m value, a slope that's given as well. Okay, so let's give that a shot. We're going to write the point slope form equation of a line that's passing through this given point. So the formula is y minus y1 equals m times x minus x1. And then we're going to plug in this value for m and this for x sub 1, 3 for x sub 1, and 8 for y sub 1. So we get something that looks like y minus, and we'll substitute 8 in for y sub 1 equals, and we'll substitute negative 4/3 in for the slope times x minus, and we are going to substitute 3 in for x sub 1. And that is point slope form. Now, this is not something that frequently you're not very often going to leave equations in point slope form. This is in point slope form. Usually what you're going to have to do is you're going to have to simplify that equation to get slope intercept form or to get standard form, right? So you would distribute the negative 4/3, and we'll talk about doing all of that in an example coming up a little bit later. So let's talk about finding the equation of a line using slope intercept form. Obviously, this is the one that you are most accustomed to. If you are given a slope and given a y-intercept, then you just plug those values in for m and b. So if the slope-intercept form is y equals mx plus b, and you are given a value for m and given a value for b, then you're simply going to substitute the given value for m in for m. Negative 3/7 goes in place of m times x plus, and the y-intercept is 5/8. And that's it. That is completely done. That's all you have to do. Obviously, those are the ones that students would say we want to do more of those than anything else. So here we have y equals, now we're going to replace m with 0 times x and a y-intercept of -2. This really doesn't look very clean, so we're going to clean it up a little bit. We know that 0 times anything is 0, so this is just going to go away. And then, yes, you should simplify that and say y equals -2, and that's complete. Doesn't look a whole lot like slope-intercept form, and you should recognize that as the equation of a horizontal line. But if you don't, there's a little bit of a summary at the end of these notes. All right, let's move on and talk about writing the equation of a line in standard form. This is the one that a lot of students don't see. Maybe they don't see it in Algebra 1. They might get it in Algebra 2, but it is something that standardized tests do use. The standard form equation of a line is given in the form ax plus by equals c, where a, b, and c are real numbers such that a and b are both not 0. In general, actually, it's more typical that a, b, and c would be integers. And it is also most common that a is expressed as a positive number. So in general, when you see standard form, you would see integers. There were usually, in almost every case, there are no fractions in standard form, and a has to be a positive number, right? Positive number. in general. That is always the case in standard form. I know that some teachers don't express it that way. But here we go. We're going to find the equation of a line passing through these indicated points. We're going to write it in point-slope form. Then we're going to write it in slope-intercept form. And lastly, we'll put it in standard form. So let's just like number these. We're going to put it in point-slope form first. Actually, we'll call that A. And then B, we're going to put this in slope-intercept form. And then lastly, we're going to put it in standard form. So let's start off with looking at what it looks like to put it in point slope form. And I'm just going to abbreviate here a little bit. And recall that point slope form is y minus y1 equals m times x minus x1. And we're going to substitute in these values. Here we go. We have a little bit of a problem. Before we can do anything, we need the slope, because we can't use point slope form if we are missing the slope. We don't know what the slope is. So let's go ahead and calculate what the slope is. Slope is y2 minus y1 over x sub 2 minus x sub 1. So we're going to say 2/3 minus 1 over negative 3 minus a negative 1/2. We're going to get 2/3 minus 1 should be negative 1/3. And negative 3 plus a half would be negative 2.5. And that's going to be negative 2.5 should be negative 5 halves. Okay, now I have a fraction divided by another fraction, so you're having to use all of your skills here. When we divide fractions, remember that we multiply by the reciprocal. So negative 1/3 times the reciprocal of negative 5 halves is negative 2/5. And then we're going to get 2 over 15 for the slope. There we go. Now we actually have something that we can use. When you plug in one of the points to point slope form, you're going to substitute in x1 and y1. It really shouldn't matter which ordered pair you use. It should be the exact same ordered pair regardless. But we also now have a slope that we can use a little bit. So here we go. Y, we're going to substitute in y minus, I'm going to use the very first ordered pair that's shown right here, y minus 1 equals, and the slope, remember, that we found is 2/15 times x minus, and we have a negative 1/2. And this was a 1 right here that we substituted in, right? So let's simplify this a little bit. Y minus 1 equals 2/15 times x plus 1/2. This is the correct point slope form. And point slope form is called that because typically you use point slope form when you are given a slope and given a point. And so we'd leave it like that. But now what we're going to do is we're going to generate slope-intercept form from our point slope form. So we're going to use this to get slope-intercept form. Slope-intercept form. Recall that slope-intercept form, our final answer should look like y equals mx plus b, where the slope and the y-intercept b are given values. So I'm just going to distribute. So the equation that we have to work with is y minus 1 equals 2/15 times x plus 1, quantity x plus 1/2. Now I'm going to distribute 2/15 x plus, and then the 2's are going to cancel, or if you write it as 2 over 30, you'd have to reduce that to 1 over 15. And now I'm going to have to add this 1 in order to get the final value, the final equation. Y equals 2/15 x plus, so 1/15 plus 15/15, because that's what 1 is equivalent to, would give me 16/15. And this would be slope-intercept form. Okay, lastly, we want to talk about standard form. So standard form, let's look at that one more time. Standard form would be ax plus by equals c, and you do want to recall a couple of things. A, B, and C should be integers, and A must be positive. Okay, so I'm going to work with the form that we have. We have y equals 2/15 x plus 16/15. And the first thing that I'm going to do is I'm going to get integers. So I'm going to multiply by whatever it would take so that everything can become an integer. And in this case, I have the same denominator in these two fractions. I don't want fractions anymore. So everything in my equation is going to get multiplied by 15 to cancel the 15, oh, excuse me, to cancel this 15 and this 15. And we're going to get 15y is equal to 2x plus 16. Then we're going to move the 2x to the other side because in standard form it's written as ax and then plus by. So negative minus 2x. Now I have negative 2x plus 15y is equal to 16. And recall that over here I said I want a to be positive. So now I'm just going to multiply everything in the entire equation through by -1 so that I can get the value of a to be positive, and my final answer will be 2x minus 15y equals negative 16, and that's the standard form equation of the line. Standard form. Notice that there are no fractions in standard form, and it is written in the form ax plus by equals c. And a and b and c are all integers. Okay, so you can get the slope and the y-intercept of a line from standard form if you just solve standard form to get it into slope-intercept form. So this whole paragraph is going to take you through what that looks like. Recall that this is standard form. If we subtract ax, then we're going to get by equals negative ax plus c, and then we would divide everything through by b. What that tells you is that this value, opposite of a over b, is equivalent to the slope, and c over b is equivalent to the y-intercept. So if you have an equation that's already given in standard form, you can identify the slope by finding the opposite of a over b and the y-intercept as c over b. You don't really necessarily have to put it in slope-intercept form if you know those things, but it's just going to depend upon you and what you prefer to do. So we've got the equation of a line in standard form. We want to find the slope and y-intercept, and we're going to sketch it. I'm going to go ahead and use this idea that ax plus by is equal to c so that I can identify the slope. In this case, let's talk about first what is a, b, and c. A is equal to 1, b is equal to -3, and c is equal to -9. So if slope is given by opposite of a over b, then that would be opposite of 1 over -3. Then the slope in this case would be 1/3. And the y-intercept is given by c over b, and in this case that would be -9 over -3, which gives us a y-intercept of 3. Remember, that's the ordered pair 0, 3, which is what we're going to plot to graph that particular line. So we've got the slope, we've got the y-intercept, and then we're going to sketch it. So remember, we would start off by plotting the y-intercept on the y-axis, x-axis. So 0, 3, from the origin we go up 3. And using a slope of 1/3, we're going to go rise 1 and run 1, 2, 3 to the right. We're going to do that again, 1 and over 3. And then we're going to draw the line. We'll go ahead and make it green if we can. We'll go through those points. It's not quite exact, but that's good enough. And again, recall that I would certainly want you to write the equation near the line, x minus 3y equals -9. Excuse me. Okay, the last little bit, we're going to review just one more time. We're going to sketch a line by plotting intercepts. I went through it pretty quickly on the last set of notes, but this can give you more detail if you want. The x-intercept is found by setting y equal to 0 and solving. Y-intercept is found by setting x equal to 0 and solving for x. Okay, so again, in some cases, be careful if you're using a program. If it says to graph it using intercepts, then you really need to do that. There are some programs that will mark it incorrectly if you graph it using slope-intercept form instead. So to get the x-intercept, I'm going to say 6x plus 2 times 0, because I have to set y equal to 0 to find the x-intercept, equals -12. 6x equals -12, and x equals -2. So if you want to know what that looks like, that's the ordered pair, -2, 0. So let's talk about the y-intercept. And the y-intercept is going to be found by substituting 0 in for x. plus 2y equals negative 12. That should be a negative 12, excuse me. And then you have 2y equals negative 12 and y equals negative 6. This is a y-intercept. Every y-intercept has an x-coordinate of 0, just like every x-intercept has a y-coordinate of 0. So we're going to plot negative 2, 0 on the x-axis. That's here. Negative 2, 0. We're going to plot 0, negative 6 on the y-axis. So 1, 2, 3, 4, 5, 6. 0, negative 6 goes here. And then we're going to graph that line. I'll sketch it in blue this time. Through these. Oh, goodness. Okay. Didn't quite manage to take care of that line form. Let's try that one more time. All right. Here we go. Through negative 2, 0, and through 0, negative 6. And that's the equation of the line 6x plus 2y equals negative 12. All right, and then one more time, just to review horizontal and a vertical line, remember that the slope of a horizontal line is 0, so the equation of a horizontal line is always y equals, and then the y-intercept, that value of b, is a constant value, okay? And then moving on to the next one for a vertical line, remember that the equation of a vertical line is always going to be x equals some value, and in this case, we're going to let a represent the x-intercept, okay? And so if we want to write the equation, let's say we want to write the equation of a vertical line through the point 5, negative 2. If it's a vertical line, what I'm concerned about is the x value, because the equation of a vertical line is x equals, and we're just going to say some number, right? We're just going to call it whatever number it is. In this case, since it has to pass through 5, negative 2, then x is equal to 5. So if we wanted the equation of the horizontal line, if we wanted the equation of the horizontal line through the same ordered pair, 5, negative 2, that would look like y equals, and then the y value of that point is negative 2, just like that. Okay? All right, and then there is a summary here of all of those forms for equations of lines. Point slope form is first, slope intercept form, standard form, and then obviously you have a horizontal and vertical line as well. Okay, so those are your different forms of lines. You are most familiar with slope intercept form, but you do need to get familiar with standard form and how to utilize that, and how to utilize point slope form to get anything else that you want. And that's it.